You can apply this thing and watch it here. But this capacitor must be pretty small not to affect any CMFB operation. Okay? Maybe much smaller, even smaller than that. Because you use 0.1 pop capacitor for CMFB, right? So if this thing is too large, there is another operation going on in parallel. Okay? Question? Nope. 이경준.
네.
Yeah, your question. Yeah, 이경준, your next question.
포인트 완성해도
Yeah. You're right. Usually, it should be valid here too. Yeah, it should be valid here too. Something like that. So then we just expect output voltage just changes something like that, something like that, something like that, something like that, something like that. But however, there is a charge injection. You should be careful about the charge injection. In any switches, when the transistor turns on, there are channel inversion charge here. This channel inversion charge is WL times VDD minus V input minus VTH or something like that. This is a channel inversion charge. When this transistor turns off, this inversion charge is dumped into source and drain, right? So this voltage will go to negative. If this is PMOS, there is a hole, positive charge. It will go up. So yeah, say to avoid the charge injection, there should be another one. This is W, this is half W. Source drain is connected together, something like that. If this is PMOS, there should be another PMOS version. Say if this turns on, red transistor turns on, red transistor turns off, and this yellow transistor turns on, it will absorb a half charge here. Okay? Then it doesn't affect the capacitor voltage. You can try. Okay, 이경준, any question? No? So, yeah, don't sleep. Okay. Let's talk about the chopper amplifier. Yeah, the purpose, this chopper amplifier is actually, this chopper is used for low noise measurement. Yeah, the chopper is actually, this is something like, this is a kind of a fan-like structure. It's revolving, and then there is some laser light passing through, and then there is a similar thing going on at the end. So there is some reaction, and there is another fan-like structure at the end. In between, there is some reaction of this laser light, right? And then there is some photodetector here, photodetector. So there is something going on in between, right? So there are some noise, and then there are some signal. Actually, this signal is, this laser light is my signal. This laser light is chopped by this revolving band-like structure. So this signal is actually it's on and off, and then it's synchronized here. And then after passing through that, this laser light is just transparent. However, this noise is chopped here, right? So by using some low-pass filter here, I can eliminate the noise. Actually, this is the origin of a chopper. In an amplifier, we can use a similar thing. So here, see, I have a multiplier. This fs1 is a +1, -1, okay? +1, -1. It just multiply +1, -1. And then I have an amplifier here with a noise. This is amplifier noise. And then I apply this chopper again at the end of amplifier. Okay, then I use, neglect A2, I use a low-pass filter. Then I have just A1 times V1. And then this noise is actually chopped. This noise is multiplied by this +1, -1. So this noise moved a very high frequency region, filtered out by low-pass filter. However, this input signal, it's chopped. It goes to pretty high frequency, and then multiplied at that high frequency, and then multiplied again, synchronized by this, right? So there may be some delay, it may match. So then this +1 is multiplied by +1 again. If -1 multiplied, and then it is multiplied -1 again, then here all was +1, right? So here my VIT is still at the low frequency. My noise is at the very high frequency, this chopper frequency. So this low-pass filter just takes this input only, okay, input version. Noise disappears. Question? This is a very powerful technique for low-frequency signal acquisition. It can eliminate this low-frequency noise, especially that one-over-f noise. This one-over-f noise is located at the very low frequency, right? So if my chopper frequency is pretty high, this is my chopper frequency, then I can move this part of noise into chopper frequency, and then my low-pass filter eliminate that part, okay? Sometimes people use double loop, something like that. So there is another chopper, FS2. I think this FS2 should be much higher frequency than this FS. Then I can further reduce. So it can also reduce input offset voltage, right? As well as low frequency noise. So in this case, my DC input offset can be microvolt, less than microvolt, if I use dual loop chopper. Question? Okay, let's just stop here.